Hello, and welcome to the session on time, speed, and distance. Today, we'll discuss some basic ideas on boats and streams. You can get in touch with me on Twitter via my Twitter handle @Ravi Handa. To begin with, some of the most basic ideas are related to the upstream motion and the downstream motion. First of all, we need to understand what does upstream mean. Well, when your boat, or let's say if someone is swimming, if the person is moving against the flow of the stream or against the flow of the river, then it is known as upstream. However, that is motion against the flow. However, when someone is moving with the stream, with the river, with the flow, it is known as downstream. The speed upstream is essentially given by speed of the boat minus the speed of the river. Not only the formula is important, it is also important to understand how we get this formula. Well, speed of the boat is the speed at which the boat would move if there was no resistance, no water flow. So when there is a resistance, when there is a water flow, like the speed of the river, what will happen? The speed upstream will be the difference of these two values. Why so? Well, let's say if the boat in still water can move at 10 km per hour, it will move in one direction, let's say from left to right at 10 km per hour, whereas the river will push back with its own flow speed, let's say that is 2 km per hour. So the effective distance gained is 8 kilometers per hour. You can think of it as if you can imagine a drunk man who for every 10 forward steps takes 2 backward steps. So what is his effective movement? 10 minus 2 or 8. That is the concept of upstream motion. Very similarly in downstream, the boat will be assisted by the speed of the river. It will be assisted by the flow. So the downstream speed will be the sum of the two values. Now, this was the method, or these were the formulas, both of them, which could have been used if you knew the speed of the boat and the speed of the river to calculate the upstream and the downstream speeds. What will you do if the question is the other way around? That is, you are given the upstream speed and you are given the downstream speed. Well, and then you are asked to calculate the speed of the boat and speed of the river. You can do that. Two equations, two variables. Once you calculate, you will get the speed of the boat as downstream speed plus upstream speed divided by 2, whereas the speed of the river will be downstream speed minus the upstream speed divided by 2. You could simply get it by adding the two equations as well as subtracting the two equations. You will get these two formulas. Once you understand that, there is one very important point that I like to make. This idea or this point that is given here is actually valid in any case. By what I mean is, it might be boats, streams, or whatever. Given that the distance between 2 points is constant, then if the speeds are in arithmetic progression, then the times taken are in harmonic progression. Whereas if the speeds are in harmonic progression, then the times taken are in arithmetic progression. Why do you think this happens? Well, for the very simple reason that when distance is constant between 2 points, then speed and time are inversely proportional to each other. So if speeds are in AP, the time taken will be reciprocal of those values and hence will come out in a harmonic progression. This is also true the other way around, that if speeds are in harmonic progression, then time taken will be in arithmetic progression. In case you are wondering what has that got to do with the topic at hand, boats and stream, well, it has everything to do with boats and stream. The point that you need to notice is speed upstream, speed of the boat, and speed downstream are in an AP or in an arithmetic progression. Why so? Because let's say if you have speed of the boat as x and speed of the river as r, then speed upstream is x minus r, speed boat is x and speed downstream is x plus r. Or you can say that they are in an AP with the common difference of speed of the river. And that is a very important idea, can be used to solve a lot of problems. With this, I'd like to wrap up this session on boats and stream. Please provide feedback via Twitter at my Twitter handle, or you can also email me at my mail ID, which is ravihanda@gmail.com. Thank you.